Welcome to the Resolve to Solve with Miles O'Brien podcast, where we go behind the scenes of the Arizona PBS documentary series, Resolve to Solve with Miles O'Brien. We'll discuss the challenges, the discoveries, and the things you might not get from watching the TV series alone. I'm your host, Elise Hu, and joining me on this podcast is the veteran science journalist himself, Miles O'Brien. Miles, thank you for joining me.
Always a pleasure, Elise.
All right, let's frame the problem first. Just how hot is it getting? It looks like Phoenix's last hottest day was 118 degrees Fahrenheit, and last year's hottest day in Sydney was almost 119 degrees Fahrenheit. That's wild.
Yeah, I think the title of this series or this episode should be Frying Pan to the Fire for sure. What a strange competition to have between two cities. But these two cities, interestingly, kind of antipodes of each other, are dealing with the same problem in their own hemispheres and trying to come up with ways to manage it because it is inevitable. The temperature is going to go up no matter what we do about mitigating climate change. We all have to think about adapting. And what I found interesting about Phoenix and parts of Sydney is that they're becoming laboratories or incubators for ideas which will inevitably be important for people who live almost anywhere, because this is a problem that's coming and is pretty unstoppable.
And before these scientists can get to solutions, they have to measure just how hot it is. And something that stood out to me about the episode were the devices, were the tech innovations that have come out to try and figure out just how hot our bodies are getting and just how much heat we're experiencing when we're outside. Let's take a look at one of these measurement tools with the acronym MARDI.
Jenny leads a multidisciplinary team and often collaborates with Ariane Medell, an urban climatologist at ASU, who's built a sophisticated mobile lab she calls MARDI, for mean radiant temperature, a measure of the total heat the human body feels in any environment. MARDI is equipped with net radiometers that capture radiant heat directly from the sun and from the hot surfaces around us.
So we have 3 pairs and they point in all directions, so they give us the heat load that the body experiences when you're outdoors in the sun.
It's the temperature we live in, not just the one we see on the weather app. The difference between the two really surprised me.
So now air temperature is about 21 degrees Celsius, that's 68 degrees Fahrenheit. But the mean radiant temperature with the direct sunlight is 56 degrees Celsius. So that's 133 degrees Fahrenheit.
Wow.
And it's only 8:45. Yeah.
She routinely tows MARDI through the playground and all over the city for that matter, gathering data on air and radiant temperature, humidity, wind speed, and direction. Together, those readings reveal how different types of shade, from trees to sails to buildings, can help beat the heat.
What was it like for you, Miles, getting to see MARDI in action?
Well, it was interesting. There I was at a playground surrounded by kids who couldn't have cared less about the heat at all. And I'm sitting there wilting. I'm listening to Ariane Medell tell me that actually the radiant heat I'm feeling from the sun at 8 in the morning was like 130 degrees Fahrenheit, or maybe even a little more than that. I'm not getting the number exactly right. But I was blown away by, number one, how much heat we feel without really fully appreciating it. Number two, that whole idea of, how everybody says, well, Phoenix, it's just a dry heat. Well, I always say, well, so is my oven.
Right.
Right. It's hot. It is hot. And coming up with ways to make it safe for kids. We as adults can kind of hide out in air conditioning and drive our cars and, do our exercise in the margins. But when it's recess time at school, it's recess time, and that's important. And kids want to get out and play. And so understanding what that environment is really like for them is really, really important, and finding ways to shade them or come up with surfaces that don't get as hot. That little red wagon that R.A.M. Medell totes around all over the city of Phoenix, Marty, really gives them insight into characterizing heat in a way that, just a thermometer can't possibly grasp.
And some of the dimensions of heat that Ariane was measuring were similar to what was happening down under in Sydney with the EMU, the Environmental Measuring Unit there. Let's take a look at that.
On the sidelines, Ollie J and his team were setting up a curious contraption they call the EMU.
It's a flightless Australian bird, but also something called the Environmental Measurement Unit.
Like Marty in Phoenix, EMU measures 4 key parameters: air temperature, humidity, radiant temperature, and wind speed.
We measure temperature in this device right here. We can move air in a certain way across that temperature sensor to get a very accurate read on what the temperature of the air is in the shade.
Humidity is measured in that same white chamber. Above it is a copper sphere that is painted matte black. It measures radiation that comes directly from the sun and bounces off the various surfaces surrounding an athlete.
And then using all of this information, we can model how hot someone's going to get, therefore what their rate of dehydration might be, and potentially how much water they need to drink in order to maintain hydration.
All right, you also spent time in Sydney, Miles. We got to see there. What's happening down under? You mentioned that this is kind of a parallel track to what's happening in Phoenix.
It's really interesting. These two institutions, Arizona State University and the University of Sydney, are the two leading centers of study on this subject. And that's because they are living in the laboratory right now with temperatures that they have to contend with. And Ollie J was the researcher who developed the EMU along with his team. And it began actually with the Australian Open tennis tournament. Several years ago, you may recall there was a tremendous heat wave in Melbourne, and some of the professional athletes were suffering severe consequences. And there were all kinds of questions about whether they should suspend play or at what point should they. And so Ollie got very interested in this. He studies this, and he is interested in heat adaptation. But he was trying to find a way to quantify heat in a way that could give the organizers of a professional tournament like that real actionable data and a decision point as to when to suspend play. And that was where the EMU was formed.
I had no idea. Why did that get left on the cutting room floor?
You want to know the truth?
Yeah.
Too expensive to get the rights to the Australian Open. It was thousands and thousands of dollars. So what are you going to do, right? What are you going to do? This is how the sausage is made, people. You have to pay for footage, and this footage was expensive. And so, yes, we left that little detail out, and we stuck with cricket, which is something we could shoot ourselves.
Yeah, and that was very cool to see. Ollie J not only measures heat outside on playgrounds or at cricket matches, but also Ollie J gave you the experience of sitting in a heat simulator. Tell us a little bit more about that.
Well, it didn't feel simulated when I was in there. It was really, so basically, if you're a heat researcher, you think a lot about what happened in Chicago in the mid-90s. There was a heat wave there which killed more than 700 people. And it kind of woke up the scientific world and the researchers to this problem. And this is, several years ago now, and they have still been studying it and what might have been wrong and what could have been done to alleviate the suffering and prevent those deaths. And the thing that really struck me, I'm sitting in there and he's recreating this heat wave, which was, very high humidity and temperatures. And I was just sweating it out. And I asked him the question, if there had been prior planning and proper safeguards in place, could some of those lives have been saved? And he said that researchers in his community say every heat-related death can be prevented. And that really struck me.
When we hear that quote, that every heat death is preventable, it makes you ask, well, then who's to blame? But it sounds like that's a pretty complex question, isn't it?
It really is. It gets into socioeconomics. It is a problem that disproportionately affects those on the lower end of the socioeconomic scale. People who don't have the money to pay the electric bill to keep the air conditioning cranking, or don't have air conditioning at all, or otherwise disadvantaged, are way disproportionately more likely to be affected by the heat. And it's kind of obvious when you say it, but it is, as a result, kind of really a silent killer. We don't see it. Of course, you can think about unhoused populations. How do they manage? This is a problem that doesn't affect rich people in the same way that it affects poor people, but there are a lot of climate issues that are that way. This one is particularly poignant because of the numbers of people who die.
At the time that we prepared for this recording, Maricopa County in Arizona, where Phoenix is located, has already reported 11 confirmed deaths that are heat-caused for 2026, with 164 cases currently under investigation. And that area is just now hitting the hottest part of the year. So we just want to put that in perspective for folks. And so many of the scientists and innovators that you met, Miles, are taking different approaches to try and solve this problem. People like the two Davids, I'll call them, that you met in Phoenix. What stood out to you about them and what they're trying to do?
Well, let's talk about David Handula first, who is among the first heat czars in the United States. I think Miami might have had one a little before Phoenix, but he's definitely in the vanguard among city officials who are focused on helping a city come up with ways to adapt to heat. And, one of the things that was just striking to me is the value of shade. Trees really do help. And the amount of shade that you can provide in a city like Phoenix, it's a challenge, right? You are out there in a hot desert, and there are neighborhoods where there isn't a lot of tree cover. And once again, we get back to that socioeconomic issue. We describe wealthy neighborhoods as leafy for a reason, right? There's a lot of trees there, and it is cooler by many degrees. So the city has been working on planting trees in neighborhoods where there haven't been enough. But this gets into all kinds of questions of, who maintains the trees, because trees do cost money to keep alive. In a city where water is something that is scarce, it is the desert after all. Is that the right way to allocate usages of water? There are all kinds of questions that come up. You would think trees would be kind of an apple pie, no-brainer kind of solution, but people actually get a little bit upset sometimes about planting trees. So he kind of walked me through a neighborhood where they had made a very concerted effort to plant trees and had significant impact. And in many cases, these are many tens of degrees differences on any given day between one neighborhood with trees and another. And then the other thing that he's done is he's pushed for cooling centers so that people who are, elderly and alone and don't have adequate air conditioning in the worst of the heat, or certainly the unhoused, can find themselves to these well air-conditioned locations that are open to the public. And then David Saylor, interestingly, has been looking at ways to we talk about the urban heat island effect, which means basically after the sun goes down, a place like Phoenix stays hot for a very long time, pretty much all night long. And if you can't cool off at night, that becomes a real problem. You kind of get a buildup of heat in your body, kind of an aggregate. And what they've been doing is starting the process of putting reflective pavement all over the city. It's early days, but the idea is that the pavement doesn't absorb quite as much heat, actually not nearly as much heat as just black asphalt would. And so at night, it doesn't have that residual kind of built-in thermal heat effect. And it reduces overall the temperatures in some of these neighborhoods around the clock. So his incubator, his laboratory is a giant shopping mall with, like 1 million square feet of retail and acres of black asphalt. But what he did was he resurfaced a section of it with this reflective pavement, and then he's got sensors everywhere to really get an apples to apples comparison about what it's like black asphalt versus reflective pavement. And he's found strikingly interesting results and improvement as a result of the reflective pavement.
I have to ask, because Phoenix is one of America's fastest growing cities, I think the last census numbers showed it has surpassed Philadelphia in population even. Does it have the revenue to implement these sorts of policy solutions? Because I imagine more trees that do need watering, or reflective pavement, or high-tech sails, they all cost a lot of money.
Yeah, you have to ask yourself, is it cost or investment? When you have a city like Phoenix that wants to remain sustainable into the next century, this is in the category of kind of necessary investment, I think. And yes, it costs money, but when you ask yourself, what's the cost of all those deaths? That's a tremendous human and otherwise cost. So you have to weigh it against what the impact of the heat is and where you want to place your investments. In a city like Phoenix that wants to remain viable, it might be a little more costly to put a shade sail over that playground. But what's the value of having kids being able to play safely in a place like Phoenix? I think, that's one of those things that it's difficult to come up with a number.
And just to go back to that quote about Chicago, if all heat-related deaths are preventable, what do you feel like are the systems and the forces that are currently in the way of preventing these deaths?
Well, I think we all, this is going to sound a little bit Pollyanna of me, but I think we all need to look after each other a little better. The fact that there are elderly folks in apartment buildings who no one's just kind of checking in on them when there's a heat wave to make sure they're okay. Little things like that could really go a long way to saving a lot of people, or making sure they have a fan, which is not a much less expensive thing than cranking air conditioners. And in many cases, fans are very effective. There are certain times when at temperatures where the fan can just blow hot air, but mostly fans are good. Encouraging old folks to put their feet in a bath of cold water is just a simple way to cool them down very quickly. But mostly it's about us kind of watching out for each other and making sure that those people who don't have mobility, don't have economic means are checked in on. And that can go a long way, I think.
So Miles, besides having to be in extremely hot temperatures over long periods of time, what were some of the challenges that you and the team faced in bringing this episode to life?
Well, I got to say, Elise, doing a story on heat, it's a challenge because heat is invisible, right? We can only get a sense of heat by, looking at the shimmering lines on a long compression shot of a street with asphalt. You see those lines that shimmer and you get a sense of heat. But heat is a very difficult thing to convey in a visual medium. And, you can write about it all day long, and it's not like, pointing a camera at a wildfire and going, oh boy, that's bad, or a hurricane. So the challenge for us was to tell the story in a visually compelling way where people could kind of almost feel the heat by watching the story. When Ollie J offered to put me in the hot box, so to speak, I was like, oh, there we go. That'll do it. Just cook the reporter and they'll get the idea.
What is something that you learned from creating this episode? Besides the cost of Australian Open rights, of course.
I learned about those. And, I learned that, Ollie J really said something that really struck me. He said, there's a lot of research on climate, which is focused purely on the physics and the numbers and building the models. And we don't do a ton of research that really looks at what climate means to human beings and how this impacts us. At the end of the day, the climate story is about how it affects us, because we are all conducting this huge experiment on each other. And heat is one way to start thinking about climate as it affects human beings. And I think we need to keep that in mind as we tell these stories generally. These events that are unfolding as we speak are all about how humans are able to react and survive and adapt. And we hope, think of good ways to mitigate too.
We should acknowledge that, of course, it takes some time between filming to distribution and getting this episode out. So have there been any developments from our innovators that you want to update us on?
I recently spent some time in Phoenix with Jenny Vanasse, and much to my chagrin, I did a great scene with her. And this is one thing that didn't get in the piece. She's actually married to David Handula. They are a heat power. Well, as I said to them at this event I was at, I said, "You truly are a hot couple," and so to speak, right? A power hot couple. And anyway, so they have two fabulous, cute kids, and we did a scene with them trying to find a cool playground and had them play around, which unfortunately also we had to cut. But don't worry, we'll make sure they got some of the footage for posterity. But what really struck me in talking to them was their sense of commitment to generations beyond. They have young children who are going to grow up in Phoenix, and what they're trying to do is make it possible for people to live there comfortably for generations to come. And I just always appreciate it when I meet scientists like that who are, they're not in it for the money. They're in it for truly making an impact, not just for themselves, but for future generations, their kids.
We like to end our episodes with any action items for our viewers and listeners who want to support this work and better support one another. So, Miles, any advice for us?
Plant a tree, maybe plant a few more. Trees are good. Whatever you may say, even in a place like Phoenix, you can plant trees that don't require too much water. They're worth having. Check on your neighbors. If you know someone who is old and maybe afraid to turn down the thermostat to the right temperature, knock on the door. And ultimately, I think it's important for all of us to recognize that heat can kill, heat can cause great harm. And we need to modify our lives around it as time goes on. And let's not forget that ultimately at the root of this is a climate problem that we still need to address. But that's something that much of what we're talking about here is going to happen no matter what.
All right, here's to planting trees and taking better care of one another and finding the shade. Miles O'Brien, thanks so much.
You're welcome, Elise.
Resolve to Solve with Miles O'Brien is a co-production of Mobius Media and Arizona PBS. You can watch the show at azpbs.org/resolve to solve. This podcast is a production of Central Sound at Arizona PBS. Our video editors are Matthew Anderson and Macy Logan. We get audio support from Joe Miller and Daniel Bevick. Our producer is Anna Williams. Executive producers, Alex Kosorik, Carol Yancho, Scott Wolfel, and Miles O'Brien. I'm your host, Elise Hu. Thanks for joining us.